Hello and welcome to Amir's guidance on math, and here we're going to learn how to do completing the square even if it's a more kind of a complicated question. So here it's asking us to do it in squared form, and we see 2x squared minus 5x minus 3 equals 0. Thus, what we do is, what I like to do is always get rid of this 2. This 2 is like bad guy. I don't like this 2. So what I do is I just divide everything in the equation by 2. So that's going to be x, what the hell, x squared minus 5 over 2x. Why are my x's so x minus 3 over 2 equals 0 over 2, right? But this is not all, because I also want to get this side to that side, since when we're doing completing the square, having that to the other side is a lot easier, especially in my books, because it kind of like opens up some spaces so you don't get that like confused about your equation. So we'll also move that to that side. Let me just link this, copy, paste, and what I'm going to do is I'm going to erase this. We don't need that. And I'm going to add 3 over 2. Easy said, easy done. But since now we did that, you see how it left some open, left some space open. Let me just move this to that side a bit. We can now add a plus here. Why are we adding a plus, you may ask? Well, because since in completing the square, we always say a equals x plus b squared plus c. If we want to continue the equation, we always, and I mean always, divide this brother by 2. So that gives us this. So 5 over 2 divided by 2 gives us 5 over 4. And then what I'm going to add over here, negative 5 over 4 actually. What I'm going to add over here is not always going to be a plus, because it's always going to be this number squared. So if we square this, it's going to be 25 over 16. We're also going to add it to this side so we don't mess up the equilibrium. 25 over 16. Done. So now that we have this, why this is important is because this gives us now equals perfect square. Boom. So now that we have the perfect square, it's easy done, and it's just happy days. Now that we have this, we can just plug it in our formula. So we don't have any a's here because this thing, which I saved you guys from doing yet. So this becomes, we already know that this divided by 2 is 5 over 4. So x minus 5 over 4 squared is equal to, and if we add those, let me just add those two up, 3 over 2 plus 25 over 16, 49 over 16. Next step is to get rid of these stupid parentheses and the square root. How we're going to do that is square root both sides. So then we go x minus 5 over 4 is equal to plus minus, because a square root can either be plus or minus, so I just like to add it from the start. 49 over 16. Now we want to isolate the x, so we'll say that's a horrible x again. X equals, um, I like to put it in the front because it just looks better. 5 over 4, it's not negative anymore, plus minus, what's root 7 over 4? Oh yeah, because that's 49. Yeah, 7 over 4. Now, that leaves us with either, um, 5 plus 7, that's 12, x equals to 3, or 5 minus 7, that's 2. Wait, that's negative 2. So that becomes negative 1 over 2. Doom. And that's how, I mean, the handwriting is horrible, but I hope I can explain it. So, in recap, we first got rid of our a over here. We moved this to that side since we didn't really want to enjoy its presence. And then we divided this by 2, which gave us b, and square rooted that, that gave us this number. Then we wanted to, since we had a perfect square, we did this part equals this part. Then we square rooted both sides, which gave us this and this, and we isolated the x, which gave us x3, or 1 over negative 1 over 2. Why this is important? Because one, in your vertex forms or usually in graphs, this can be super helpful, and two, in a super complex or like really difficult quadratic equations, using completed square form is much easier than wanting to like factorize or use the quadratic formula. For example, look at this equation, this. I really don't think anyone can just go on the top of their mind, oh, the factor for this is blah blah blah. So, I mean, square root form, my favorite form of doing quadratics. Thank you.